Okay, at this moment we figure out the unit step response. It means that if we applied input, we tried unit step, then output are given 1 minus exponential minus t over tau, and we would like to find out the impulse response. It means that if we try input with delta t, then you know what, that the delta t is a differential by taking difference of unit step of dt is the unit, this value are equals to delta function. So the output response, usually impulse response expressed by ht, impulse response will be dvo over dt. So by taking derivative, these terms will give 1 over tau minus t over tau. Or we can express it in this way. Okay, now we have impulse response. So we didn't directly calculate the impulse response from these differential equations, but indirectly we can find out the impulse response at here. First, we tried the unit step and figure out the step response from here. But we would like to know the impulse response. If impulse is applied at the input, what will come out? That can be found out by these relationships. Unit step is derivative time, that gives the impulse response. Then the output, you know what, this one is a linear system, so the same differential operator applied to the output, then that will give the output impulse response. So this is the impulse response. In this lecture, I explained how to solve the RC circuit. We build up the differential equation and try to solve the unit step response, and then figure out the impulse response. Then the next question is, what's the meaning of the impulse response? At t equals 0, we hit this circuit with the impulse. At a short period of time, we hit this RC circuit, then there will be some response will come out like that. Okay, if I plot that one, this is time, and this is event I called it at t equals 0. Then output response, okay, this one is delta t. Delta t is applied to the RC circuit, then the impulse response are given like this way: 1 over tau times e to the minus t over tau. This is the ht. Actually, it's a causal system. You know, the input is applied at t equals 0, and after t equals 0, output is come out. So before t equals 0, impulse response does not come out. Only at the positive time, ht is come out. Okay. So if we apply the impulse at t equals 0, the response will come out in this kind of pattern. The meaning of this one is a memory of the system. I said that this RC has a memory element, capacitor has a memory element, so it has this kind of patterns. If signal is applied at certain times, it has some memory like that. Then I would like to let you know that the meaning of this impulse response, if hit these times, it has affecting the future, affecting the after the t equals 0, like this kind of pattern. This impulse response serving as a weighting factor. It means that this is time. Okay, so the same system, I mean, if we apply the impulse at here, then output is this one. Then if I applied any input, then what will come out? YT. The question is this one. What's the relationship between input, the output to the input, and impulse response and the delta? So the relationship should be defined from these figures. Here is the input signal xt changing like this way. Okay, here I would like to explain the meaning of impulse response. Impulse response is related to memory of the system. So this means that here is a system. An RC system is a linear and time invariant. Okay, RC circuit is a linear and time invariant. So here, if you apply the delta functions, then output are given as ht. ht are 1 over tau e to the minus t over tau. Okay, so this is the response. To understand the meaning of this one, let's try to see any kind of input. Here is any xt are given like that, and this is time. We would like to figure out xt is applied here, then corresponding output will be yt. We would like to find out the relationship, this output to the delta function and input and impulse response. So yt is related to in somehow these three signals, input signal and impulse signal and impulse response. Those three signals are related through the linear systems. Okay, we would like to figure out the relationship. The key point is impulse response. That will explain by itself the meaning of the impulse response. Okay, so at here I would like to calculate that t equals 0 point is this one. So I would like to calculate the output at t equals 0. So any time t equals 0. And I would like to find out the effect of the input before tau of this event. So this is tau earlier input is this point. So this time point is t0 minus tau. So this output will be x t minus t0, t0 minus tau. So this output, this input will affecting to the output in somehow. We would like to figure out in that process there is some relation will be show up. To figure out, I would like to write down the sampling function like this one. Here x t minus xt, see that delta function. These delta functions can be written at here. So I would like to making a delta function at here. This delta function can be described by t minus t0 minus tau. Okay, so you can see this one is a shifted version of the delta functions. Delta functions are occurred at this times. t0 minus tau is the event times, and that is multiplied by the input signals. Then we can write this one into this way: 8x time x t0 minus tau. Okay, I make it slanted version. See that? Delta t minus t0 minus tau. Okay. Now this delta function is scaled by x value, scaled value. But we know that the RC circuit is a linear and time invariant. And input, now this is applied. then what will come out? At here, I said that this RC circuit is linear time and invariant. So this scale factor is affecting like this way. The output is scaled this much. Okay. This should be producted. Before, you know that this is the input now. This is the input. This is just the scale factor because this one is dependent on time. The delta t is applied at here. Delta t gives ht. Then delta, there is some time shift. Because this one is time invariant, output is a shifted version. So ht minus t0 minus tau. Okay. We can plot this curve with respect to time. Let's try to plot that one with this curve. Okay, input is applied here. That is scaled version. So I can write down the equation. This equation can be written like this way. That is scaled by this much. X t0 minus tau times h t is shifted this much. Okay, so this time function will follow is all the way 0. There is some scaled impulse that will follow like that. This is time variable. But we would like to know the value at t equal t0 times. So we replace the t with the t0. Then this output will be x t0 tau minus tau times h tau. So if we replace with a t with a t0, then t0 we cancel out and tau will come out. So this is it. So now think about what's the relationship to the output of this one. At this time's value are contributing to the output by this much scale down. So okay, if input is applied here, that will follow this much contributions, and this one will contribute that much. So this means that the scaled by h times this much times. So we can change the tau in every those past history. So far long before input will be almost decade out, but the near past will affecting more like that. By summing up all the past history contributions, summing up at t equals 0, that will give the output. So that operation can be explained with the integral. Okay, so we can think about x t0 minus tau times h tau times d tau will give y output. So tau is changing from 0 to the infinity in the past history. Okay, so we call this one is convolution. Okay, so now what is the impulse response? Then what is the convolutions? Okay, think about it. So what's the meaning of this impulse response? Another point to understand the convolutional operation is this one. Okay, I said that the y tau. Okay, now I think yt 0 at t equals 0 times output will be x t0 minus tau changing from 0 means current times, and infinity is far before times. Because this one is a causal system, we didn't output didn't affected by the future value. It's stopped at here. So this one stopped at here. If it's non-causal, you can express in this way. In case of non-causal system, it means that the future data affecting, then we have the taking minus infinity. But we will focus on the causal system. So this is the upper response. I can replace t with any kind of value like that. At time t, the output are given like this equations. You can think about the ht, impulse response is weighting factor. So this output is weighted by this much. So it is decreasing. Usually it's a decreasing like that if it is tau distance. Then h tau is this much. It's a scale down that much. That is a scale factor at here. Okay, so tau before input scale down this much. If tau is 0, then this the t equals 0, ht equals 0 will affecting to the scaling the input like that. And you can do the change of variable. Let me rewrite this one into this way. Let's tau prime as t minus tau. Okay, then tau changing from 0 to infinity. Then tau prime will changing from tau is 0 is t. Okay, if tau goes to the infinity, that goes minus infinity. Okay, changing from t equals 0 cases, it's a tau prime will become t, and tau is infinity, tau prime will minus infinity, and the another one is d tau prime are equal minus d tau. Okay, then we can do the change of variable. Yt can be expressed in this way, 0 to minus infinity, and x tau prime, and see that h at this moment the tau is t minus tau prime. See that tau prime, but the d tau prime, but d tau prime and d tau has a negative signs at here, so we have to change the integration directions. Okay, I'm sorry, it's from t to the infinity. Sorry, it should be looks like this one. This integration are equals to this one. Okay, by change of variable, we replaced this part with a t prime, this part as a t prime like this way. Then tau changing from 0 to the infinity, then tau prime will changing t to the minus infinity, and the d tau prime is minus d tau. So this negative, the integration direction are changed, the minus infinity to the t, minus infinity to the t. This t is output time t. The t minus tau are replaced by tau prime and ht. H tau is t minus t prime, tau prime. So we can rewrite that one. So we would like to interpret these equations. So this equation can be expressed like this one. The earlier input is a scale down this much. So what about this one? In these equations, we can plot the h tau, t minus tau prime. Tau prime is these directions. So h tau prime will follow these directions. This curve is h t minus tau prime. Okay, t prime changing from t0 at this moment it's a t. Okay, this one is t to the minus infinity. Okay, t to the minus infinity. So we can multiply input with the scale factor, this one. So input scale factor times h tau. At this moment, this value will be, if tau prime is you can see that the t minus tau prime is tau. So this one is actually h tau. Okay. So this ht0 minus tau are scaled by this much. This is the same. You can think about the reversed impulse response. Impulse response looks like this one, but we are taking the negative signs at here. So ht minus tau prime are this kind of curve. So reversed impulse response are scale factor of the input signals. I can rewrite this one. This is input is applied like that, and we would like to measure the output response at t equal tau t. Then we plot this one, tau changing from t to the minus infinity. If tau prime is t, then h0, that's this point. So h0 to, if tau goes to minus infinity, then this term goes to the infinity. So this direction. You can see the transformation of the reverse transformations. You know that this one is reverse transformations. Due to this reverse transformations, the signal patterns looks like that one. This one is xt. So if this distance is tau, okay, then this value will h tau. So this one is a scale factor for this input. Okay, this is the t minus tau prime. So t minus tau prime. Okay, so reversed impulse response is a scale factor. If far before input, scale factor is very small, but near one, scale factor is higher. Okay, scale factor are decreasing in that way. So by summing all the past history will give the output. You can think about the convolution has two different expressions. So what's the meaning? In the statement, I said that convolution is can be expressed like this way. Convolutional operation is past history. You know that all the past input, so already input is applied, not the future one. All the past history are weighted sum that gives the output. So convolution is this one. Past history are weighted and sum will give the output. So weighting factor is the impulse response. Okay, here. So I asked what's the meaning of the impulse response. So impulse response is sort of weighting factor for the system. And to find out the actual system output, we take a convolution operation. So think about what is the meaning of the impulse response and what is the convolution operation. Okay.